Chances are, as a kid, you probably spent your summers bouncing around on a trampoline, which comes from the Spanish word for diving board. The first trampoline-like devices were designed by the Inuit people, who used walrus skin to throw each other into the air. American inventors in the late 19th century borrowed the Inuits' invention and designed a trampoline-like net that firefighters used to catch people jumping from burning buildings. Invented in 1934, the modern-day trampoline was introduced by George Neeson and Larry Griswold, who added springs to a synthetic fabric to increase the bounciness. Since then, their invention has been used in the United States Navy Flight School training American and Soviet astronauts, and for therapeutic use. A trampoline appears as nothing more than simple fun, but is actually a complex array of the most basic laws of physics. Kinetic energy is defined as some mass that is moving at some velocity, or 1/2 mv squared, where m is the mass of the object and v is the velocity. The kinetic energy of a person is greatest just before contact with the trampoline and just after being pushed off the trampoline. This is because it is at these instants that the person is traveling the fastest, which results in the greatest kinetic energy. When the person pushes down on the trampoline, kinetic energy is converted to potential energy. Potential energy is a function of an object's mass and height, or mgh, where m is the mass of the object, g is the force due to gravity, and h is the height of the object. For instance, an apple at 10 meters has less potential energy than that same apple at 15 meters. As potential energy increases, kinetic energy decreases. In 1660, British physicist Robert Hooke first stated that the force needed to compress or extend a spring is proportional to the distance. Hooke's law is stated as F equals negative kx, where F is the force, k is the spring constant, and x is the displacement of the spring. Because a trampoline is essentially a disc with springs on the outside, Hooke's law applies. Hooke's law states that the springs will work to return to equilibrium. Therefore, the force exerted by a person on a trampoline will be the same that the trampoline exerts on a person. So next time you are on a trampoline, think of Hooke and his laws and be glad you're not bouncing on a walrus.